Hey, what's up guys? This is Akshay from AS Learning, and in this video we'll be seeing a very common issue in RAG applications, which is context window getting full. So let's try to understand what is context window. So whenever we ask a question to a LLM, the LLM generates output. So in generative AI world, it is the tokens. One token is equivalent to 3-4 characters in English language. And whatever ask question, prompts, and other things, they come as a part of input token, and the output which is generated, it is a part of output token. Now, models have a certain context window in which they operate, and accordingly, we have different pricing tiers set by companies to have bigger context windows and all these things. Okay, and we need to operate in this certain limited token space for the generation of our output. Sometimes if this space gets filled up, so we get a very common production issue that the context window is getting full and we are unable to generate output. So let's first try to understand what is the composition of this context window, and then we'll be seeing different ways in how we can bring up improvement into a RAG pipeline. Okay, so let's understand what is this context window made of. It's made of input tokens plus output tokens. So before generation, it is our user input, the system and the developer prompt which we have set as per our use case, the outputs of our tool, our history, and our retrieved documents from VectorDB. And after generation, the output tokens also take space in this context window. So it's a composition of our input tokens plus output tokens. Now let's take an example of GPT-4o, a very common model used very heavily in the industry by OpenAI. It has a context window of 128k tokens. Okay, and it has different versions for with its different versions. It has different output token limit. The maximum which we have is 16348k of the higher version, and we have 8k also. Okay, now what happens is we need to operate in this 128k context window token length, and let's say suppose our input token itself has taken, let's say, 120k. Okay, now even if my version of GPT-4o has a max output token limit of 16k, but still only 8k are available with me for generating the output. Hence the LM will generate the output from that 8k itself, which I have explained in this second line, that the effective output token context is the minimum of configured output token limit, which is 16k in case of GPT-4o for my highest version, and the subtraction of context window and input tokens. Okay, now we understood what is context window made of. Now let's see if we start seeing such issues. The root cause can be across developer prompt, our tool outputs, history, user questions, and retrieve docs also, because these are some things which are in our control. Even the output token is also in our control, but it is like we are setting some rules and our LLM is generating output for it. Okay, but the root cause, let's see how the root cause can be across these different areas of system prompt, tool outputs, history, and retrieve docs, and how we can approach this problem for better outputs. So first we'll be seeing the things which we need to check for system and developer prompt. What we do is in our version 1s and POC for big grand outputs, we create a very detailed prompt, and there's a lot of repetitions also. Very common is you are a helpful assistant and you are this, that. It's repeated quite often. We don't want repetition. Then we don't want duplicacy. We don't want duplicate formatting. Let's say it's happening in system prompt and developer prompt also. In system prompt also you are saying that you are a helpful assistant. In developer prompt also we are saying that you are a you are a helpful conversational assistant. We don't want duplicacy. We don't want repetition. Then we want our style to be concise over detailed. We don't want over specification or over detailment. No, we want it to be concise, short, and to the point. Then we don't want full sentences. We want patterns and structured responses. We want patterns. We want certain rules, like certain style of patterns, instead of writing full sentences that you are I want the first key to be, let's say, a, then I want its value to be a string value. No, you can give it a structured JSON with just a simple string key as a, and a data type string with some value as a value. The LLMs are smart enough to understand. We don't want full length sentences. Even while setting up as per use cases, we want it to be concise and not full length sentences. Whenever we can try to be concise and use patterns and structured responses, it is better to use it. It is saving our input tokens. Then in case of few shot prompts, it's a very popular thing. Few shot, one shot, zero shot, and it's very heavily used, and people try to give it example that this is this is that, then this is this is that. It's better if you can use distilled rules over a few short examples. Few short examples takes a lot of tokens into from a context window. So if it is possible to set up some rules, it's nice. Okay, let's say you can say that uh, execute the mathematical operation as per BODMAS. Well, you don't need to give and explain what BODMAS is and how each thing works. Let's say if you have a formula for a certain operation, you don't need to explain him the entire formula. You can just write those certain rules, and you don't need to create a example and the output pattern. No, it will understand from distilled rules. And this is a bit of a trial and error, okay, but we need to be concise. So the trick here is we need to keep the prompt static, short, and concise. We don't want dynamic prompt. We want to avoid dynamic prompts also. Custom prompts are heavily used, and when prompts are in users control, we need to put some check on UI that it should not be on certain length. So we need to keep the prompt in check, static, as much static as possible, short and concise. The next thing is tool output. It should not be very much detailed. Sometimes you do a web call, and then from the web call we get a detailed answer. No, we just only want to have the things which is important to us into our context window. For example, the good response can be that the title is product, weight is 10 gram, then that the title is product and weight is 10 gram. A very detailed answer, and this is something which is into our control. Our tool call is going, and we can control its response and then let it go into our context window. Okay, we can perform some pre-processing operation there. The next thing is history. History is used into conversational AI assistants, and we should not blindly append full histories. It will fill up the context very quickly after certain conversations, and we cannot do long conversations. The trick here is to summarize old conversations which are less important and keep the recent ones to have ephemeral memory. And we can summarize the old ones, or we can create some it's a bit advanced, but we can create some graph based connections. First, if it's graph based connections for understanding the structures and relationships, and such kind of memory support is there in LangChain also, where we can use a graph DB for storing our relationships and structures instead of an entire logs or entire text or entire transcripts into our history. It takes a lot of space into our context tokens. Then we need to keep it small and remove irrelevant things, and we need to remove repeated things also. In conversational AI assistant, history is the biggest reason for context window getting full, and this is really it's a big challenge, that how we can. The easiest thing is summarize the old conversations, keep the recent ones, but it's really tricky because we are losing out on context, very important context, and here we can use some much more advanced techniques from network X, where we can create a knowledge graph, see the patterns of our domains, and accordingly create a structure from which only the important things will remain and the irrelevant things can be removed out. Okay. Then the next thing is a big culprit, retrieval documents. We do a query goes on vector DB. We have some top k parameter set and it returns big outputs and the context window gets full. So what we can do is we can apply selective re-ranking. Let's say if you have applied a re-ranker, 100 tokens are coming, you can have a cross encoder there for doing re-ranking and just not performing re-ranking on everyone, doing selective re-ranking and picking only the important ones. Okay. Then we can play with the top k parameter as per the query length and confidence threshold as per the embedding model, and we can enforce some capping that the chunk cap is up to a certain token, some retrieval cap, and the basic thing can be retrieve top k and just do selective re-ranking and to avoid redundant things. Okay, so these all checks we can apply on the retrieval documents. Then one step further, which is chunking strategy. We are using re-ranking to deploy to drop low value chunks. Okay, instead of putting all the chunks into our context token window, deduplicate the similar ones. The chunks which are not important, just remove it. Reduce chunk to optimum size. It depends on the chunking strategy, how you are splitting up the text, whether you are using semantic chunking or not. Semantic chunking is very popular these days. Use appropriate text splitter as per the data to be vectorized. Instead of just simply doing character text splitter, use a recursive character text splitter, use a semantic chunker, and it helps a lot. Use metadata for avoiding and using filtering wherever needed. Timestamp, the source of the document, some key tags which we need, let's say some which can be used in certain ways. So having metadata also helps us. And then all these things which we do, we can perform A/B testing here for different chunking strategy, retrieval, compression, and summarization technique. We can do A/B testing and see which works the best for us. And we can use token counters like tick token for analyzing all the tokens being consumed at every stage. Okay, and we can have a track of it. And last but not least, I'll say the Brahmastra of this problem is use model with higher versions. Yeah, so that's the easiest thing to do. Use models with higher versions, higher context windows, and output tokens limit. And yes, sometimes that is the only solution you need, especially if it is not a conversational AI. In non-conversational AI, this is a very good solution, but in case of conversational AI, we have options of playing around with these things and trying to bring out the best into our constrained memory and compute resources. Okay, so that's it with this, guys. If you learn something new, give it a thumbs up and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.